would like to start with the panel discussion. So I would like to invite all our panelists to start with the discussion. So starting with you, Mr. Gupta, since you were talking about workspace comfort, what developments are taking place in air handling technologies to enhance indoor air quality, especially for workspace comfort?
I mean, for workspace comfort, I think there is a lot of good cooling technologies that are coming about. In cooling specifically, I think we are looking at evaporative cooling being one of the biggest new trends. Folks at CEPT are working very hard on bringing around new evaporative cooling technologies which are very energy efficient. They also allow us to put in more fresh air, basically just cooling. Of course, cooling is one very big part of it, but along with that, being able to bring in fresh air in different forms. There is a lot of focus, not just in India but globally. There are many companies now that are trying to bring in such technologies. So I think we are looking at an era where precision cooling, evaporative cooling is going to become more mainstream, as cooling becomes very important, not just for offices but also for homes in Chennai, in India, in Mumbai. Efficient cooling technologies are going to get more efficient, and they're going to find more ways to bring in fresh air.
Thank you, sir. Mr. Vikas, would you like to add something to this?
Yeah, of course. Abhinav Gupta has already told the evaporative cooling and this is the upcoming trend. And I would just like to add, even if we can control or add the number of technologies or bring the technologies, we will have to observe the minimum glitches where we can observe the small changes will make the bigger impacts. Like I have already shared the case study where the cassette units were running even if the 24 degrees Celsius were maintaining. But after the temperature approaches to the certain value, there is not shutting off the cassette units. Then we have founded this glitch and we have just overcome this glitch again by the IoT. So if we have to improve the air quality or the efficiency, we will have to monitor, observe, and implement these practices to overcome this problem. That's from my side.
Thank you. Mr. Joe, would you like to add something?
Yeah, so Vikas has pretty much mentioned what I've intended to say. That's monitoring. Like you need to constantly monitor and analyze how your system is performing. Similar to what was mentioned in the presentation earlier by Priyanka, that you have hyperlocal sources of pollution in the outdoor air. Similarly, you have hyperlocal sources of pollution in the indoor air as well. So it's very important that you need to monitor it thoroughly so that you can have a data-driven action plan. And like it could be for cooling, for purification, whatever your parameter for success is, but you need to have a data-backed action plan.
Thank you. So, Priyanka, since you were discussing about pollutants at your presentation, so air pollution is increasing in many Indian cities. So, amid concerns about pollutants in air, what measures must be taken by the industry to introduce cleaner and purified air into various indoor spaces?
Right. But before that, I would like to add to the previous question as well,
Sure.
where we were talking about the developments that have happened. But I would like to, throw some light on what should also be there. So Abhinav mentioned that the case of air purifiers. So it's most likely the case that, and it's mostly there with all any equipment that you take or any technology that is there. So the installation is easier, but operating it into with the standards that came with the equipment, it's a lot harder. He showed the filters. I don't know how many people are still, even at a household level, are checking their filters. Even if they are checking their filters, what is the motivation? Because the cost of changing the filter is, if you change 2 times, you can go for another filter, right? So the developments in technologies that should happen is modifying the longevity of such products. Such products, by that I mean HEPA. I'll take the example of something that we did with school children. So there is an ideator fellowship that we ran under one of our projects, and in that, one of the solutions that children were working on was to improve the efficiency of HEPA filters, because HEPA filters, they just they're not recyclable, most of them, right? So they are generating waste. So whenever we are thinking of solutions, we should also think of circularity, because that's the hot topic, not just because of being sustainable, but also because it brings cost and to the user to use anything efficiently. These are the things that need to be thought of at the planning stage. So that is on first one. Now coming to the second question, which is what are the things that an industry can do. So if you ask me as a person who is researching on this, the first thing that I would like to say is, why are we even coming to a place where we need certain technology? So we need solutions where we can reduce pollution at source. Why don't we aware people between choosing certain items where where there is, like, say for example, if you were to go for a DG set, right? I'm not talking about a larger policy scale, but if you were to choose between an equipment, why don't we choose something which is less polluting? So that is reduction, and that industry can do at the at the point when they are making the planning itself, whenever they are coming. So these are the strategy. So the reduction at source is first thing. Now coming to the existing processes, with technologies like what Abhinav mentioned, what Vikas mentioned, what Liju mentioned, we have everything, but the only problem is we are not trying to optimize the already existing processes. We are okay with what we are doing right now, and we just when a technology comes to us, we just look at the case study and think that this will be, so there will be a customized solution that will be appropriate for a particular person. So optimization of the existing process is something that a company or whoever is trying to reduce the pollution that they are generating, they should be focusing on. I will just start. I know that other speakers might have some other good points. So these 2 points I'd like to focus. Yeah, thank you.
Thank you. So can you, how can the source of pollutants be tackled, or its impact can be reduced at the point of origin? You were talking about pollutants previously.
So a reduction of pollutant, obviously we have emission control equipments, we have air purification, so that is there. But reduction of pollution can also help with come with, like I showed you certain items, right? So these were sources of pollution when you are doing it outside, right? So these are something, there are some lifestyle changes that you can do. Like you can just be aware that, okay, maybe in your vicinity, like say for example, I'll just take the live case where there is no awareness among the society of my own society members of my own society, who are making a case for guards to take warmth from burning coal. They are actually bringing coal for them to burn without even and that is going to happen in a closed space. So they are actually not doing good, rather bad for that person, even for themselves, right? So that awareness, lifestyle change, why don't we go with a more better solution, which is healthier for the person who is going to be impacted, and also for the surroundings. So that one lifestyle choice is something that. Secondly, there are certain nature-based solutions that we should be exploring. As a researcher, we are researching on that. As a technology provider, why are we innovating new things when there are existing solutions which can be exploited, and then they can be made easily available to the general public or the user, right? And I really like the presentation that Lijo mentioned. It's not just about having the data. That's the problem with data. People have, he called this a set of 16 billion, if I'm correct, which is causing you to have a paper as high as Mount Everest. So basically, data insight should be there, which is consumable. It's not like you give them, okay, so the point that I wanted to make in my presentation was, you can't go and tell a layman, okay, your PM10 is this high, what will he do with that, right? If you tell them that, okay, during last year, you have inhaled this much, and my monitor or my air purifier has saved this much, which might have caused this from the scientific. So a correlation which is more palatable, more consumable, and more understandable to a layman person, because all of us sitting here are intelligent people who are experts of their own field, but the user might not be that well versed. So that awareness, the conversion, the translation of this technical data into a layman palatable data is very much required. Thank you.
Thank you. Thank you for sharing this. So, Mr. Vikas, I would like to divert it to you. How do smart HVAC systems contribute to energy efficiency while maintaining optimal indoor air quality?
Okay, so the energy efficiency sector is pretty much higher. If you can see the air handling units, the previously it was not interacting, it was not working on the real-time basis. So now the IoT has been come up to the and taken the conventional PMS places. So where the real-time data can adapt to the current conditions, and likewise the air handling unit will be modulated on the basis of that. Just I will give the small example. If the certain space occupied with the 20 people, and the current temperature requirement is 24 degrees Celsius. So previously, in the conventional PMS system, we had the overrides, the commands, the set points. Once we set the 24 degrees Celsius set point, no matter the number of people will increase or the surrounding condition will occur, the system will perform just only for the 24 degrees Celsius. Like, if you take this forward and if you can replace this with the IoT, so even if after the 10 people, if there is only 2 people or no one is there, so the system will adapt to the current condition. So that it will react. There is no space, there is no occupancy. The system will shut off the walls of the cooling walls, and again the damper position. So likewise, the each and every devices can be modulated on the basis of current conditions. Certainly, you can save the energy from these kind of the techniques. That's all from my side.
Thank you, sir, for covering this point. So, Mr. Gupta, how does the design of AHU fan system impact its energy efficiency and performance?
I mean, so like it definitely has a significant impact on the energy efficiency, performance, what kind of fans you're using. Nowadays, I think because of a lot of improvement in motor technologies, thanks to EV and other places where a lot of these new kind of motors are being used, there is a lot of, I mean, not just AHU fans, we're talking about ceiling fans becoming tremendously efficient because of new types of motors and new types of controllers and so on and so forth. What I also believe that AHUs, what happens sometimes when in AHU design, and what we've observed in AHU design, is that there is usually not enough provision for a fresh air intake, or a fresh air intake has not been thought through with in terms of the occupants targeted in mind. So you might have, like, they might have, okay, so they'll say that, okay, let's put in 800 CFM. There's no real thought put into it, like why 800 CFM of fresh air should be there. So, you know, like, and I mean, this is not new science. Like Ashley has been talking about how much CFM per person should be there for a very long time, and it's a fairly straightforward number. So but that most design at the design level, that thinking is not happening. There is generally a process of following a standard BOQ or replicating that BOQ without considering where the situation is, where is it located, can we put in fresh air, and then once what happens is that once that is already put into place, it's very difficult to change it in retrofit. If it's already designed that way, then changing it becomes very much difficult. So a lot of times people run after the efficiency part of it, and efficiency in terms of energy efficiency. And a lot of great work has been done in terms of, as I mentioned, new types of motors, new types of chillers, new types of technologies to do precision cooling. There's a lot of great work, but along with that, putting enough motor capacity, fan capacity to bring in fresh air is something that is still overlooked. And I think moving forward, it's going to be less overload. And it is something that, in practice is already there in the Middle East. And now I think it is going to come slowly, steadily in the Indian practices as well.
Thank you for sharing this. So coming to Mr. Jose, can you tell me what emerging trends in air engine technologies can offer promising solutions for creating healthier indoor spaces?
Yeah, so I am not the right person to talk about the emerging trends, but what I can tell you about is, there's a lot that can be done with the existing systems. Like, one of the perks of being in the monitoring space is that, and also working in sales, is that I get to travel a lot and with my air quality monitor. Now, what we've observed, this is in addition to what Abhinav mentioned previously. People are focused on energy efficiency and new technologies and a lot of other things. Sorry to digress from your question a lot, but the reality is that a lot of things are designed for an ideal use case, keeping energy efficiency in mind, keeping the occupants in mind. A lot of things are done, but the operation of those things is not adequate. Like there was an instance recently where we stayed at a hotel and we had a monitor running in the room throughout the night, and the next day there was an event, like an ASHRAE event, and we spoke to the chief engineer saying that you're wasting a lot of energy running your systems the way you're running, and we can definitely make out that you have a very efficient system, like you have a state-of-the-art system, because we can see the fluctuation in the parameters. So he was like, no, it's not like that. We have it under control. You might be misinformed and everything. And that's when we told them that we have the data, we can print it out for you and then show it to you. And that's when he says, "Saab, bijli ka bill itna aayega." Right? So then we are obsessed with new technologies. That's a good thing. That's the mother of innovation. But what I'm trying to say with all this backstory is that we should be focused on what we have and how to make the best of it.
As you mentioned monitors, so how should air quality monitors be used to monitor indoor air quality in view of rising pollution in indoor spaces?
So indoor pollution is generally 2 to 5 times worse than outdoor pollution, and we generally don't understand that. Like, we cannot digest the fact that our indoor air would be more polluted than outdoor air. Okay, and coming from me, like I live in Delhi, and I've measured my indoor pollution around 1,000 micrograms per meter cube, and the outdoor would be 400, 500. Okay, so there's a lot of talk about IAQ monitors and using them properly. They just give you readings, right? For a layman, like what Priyanka said, it's just data. What do you do with that? There is no, explanation of what do you do when your PM 2.5 is 1,000 micrograms per meter cube. So the best way to use an IAQ monitor is to, like, there's a lot to it. Like, I cannot mention all the points here in a succinct way. What I would say is that there's a lot of awareness that needs to go in. And like Priyanka mentioned, again, communication is one of the most important things that needs to be put in. Like, most of the times what happens is people who buy IAQ monitors, they are only concerned about AQI values. And when we had home-line devices that were sold to end consumers, we would tell them that our devices gives AQI based on PM 2.5. Now, most of the consumers that have IAQ monitors, they don't really understand that AQI was meant for the outdoor. And if you want to measure the true AQI, if you have the Indian AQI, you have to measure 8 different parameters, and then a lot of science behind that. So they figure that if they have an IAQ monitor and the AQI value is showing 400, it could be that the device is measuring PM 2.5 and some other parameter, and the reason for high AQI could be either of them, and it's not clear to them by just looking at the AQI value. So yeah, so without going into too much detail, I would say that there's a lot of awareness and knowledge sharing that needs to be done if one needs to use these IAQ monitors properly.
correctly said. So, Mr. Gupta, coming to you, are HEPA and UVC filtration systems only options for purifying indoor air quality to eliminate pollutants and pathogens?
No, not really. These are the oldest and the most well understood, and the most prevalent and available around, at least because of their excessive usage or basically baseline usage in the healthcare system, in the pharmaceutical system, in the electronics manufacturing areas where you talk about clean rooms. HEPA has been used for years and years and years. In fact, it is so well entrenched in the ecosystem that if you talk about HEPA, it must be a hospital or it must be a pharma. When the first time we told one of our building clients that you might have to put HEPA into your HEPA grade filters into your HVAC, was like, we are not running a hospital here. We don't need it. I was like, yeah, you don't have needed it, but the PM is 400, so you can't really use a more weight filter or a more 15 filter. But coming to, like, as I said, these are well entrenched technologies that are very, very well known, very easy to manufacture. There is a very good supply chain for it. But we as active buildings, we've been working with our data with also people who are working on extremely low cost, or as Priyanka mentioned, we're talking about circular economy, or being able to use material circularly. So there are basically people who want to use biodegradable materials that can be woven into a HEPA type system. Maybe you might have to put more filters, if not lesser as how much you would have put in for a HEPA. Maybe you have to put more of them, but they're biodegradable. So that is one of the biggest things. There are also technologies that are coming up that are not technologies, but I would say about engineering. I think it's more engineering, where people are using systems to reuse HEPA. Not by washing, but by extreme high intensity vacuuming, or very you can just use some kind of pressure to completely get the materials out. There are those kind of technologies as well, which I think are important. Even those are important to be used. They might not have the same level of efficacy as they were before the reusing, but at least you're able to reuse the material and it's not going into a landfill, right? The other part, I think is that is coming up. There is a lot of the filterless technologies. Now, generally, when it comes to filterless technologies, I am a little bit cautious, because anything that is filterless might change the chemistry of the indoor air that we do not understand completely. Specifically, when it comes to ionizer based systems that have been around for a very long time, it's not that ionizer systems inherently are bad. Okay, that's not the statement that we are making, but there have to be regulations. And in the entire globe, only the state of California has regulations that talk about the amount of permissible ozone emissions coming from an ionizer system. And there are ionizer systems being used in California that follow the law. So if you follow the law, the amount of ppb of ozone emitted is very less. Then of course, go for it. Go for an ionizer based system. There are people making better ionizer based systems as well, that further reduce ozone. But just because it doesn't emit ozone doesn't mean that it doesn't emit anything. It's ultimately a chemical reaction. So it might release something that we don't know how it's altering the indoor air chemistry. So that's one also kind of solution. So I feel that there is a lot of emerging trends. There's a lot of exciting stuff that is happening around air quality. But we need to understand that unlike water, air can seep in very easily. The volume of air to be breathing in is very high. So by making these kind of new technology changes, it needs to be completely understood before we start adopting it in a mass manner. Similar with UVC as well, right? In UVC also, I don't think there is any more new thing that you can do in the UVC bulb itself. Now, of course, there are far UVC and ultra far UVC that are being touted as the new technology base. Typically we hear that UV is bad for your skin, bad for your eyes, but far and ultra far UVC claim to be safe. Now this claim is still 3 to 4 years old. We need to wait a couple of more years. We need to see more long-term effects of the technology. If the technology itself is not 10 years old, then you can't have long-term. results. So far UVC is also, I think it will be used, might be used in a slightly different way. South Korea already has sanitizers that are built with far UVC systems, so they are not putting alcohol, which again for environment is a good thing, because excessive alcohol and sanitizer alcohol in the wastewater system is not a good thing for microbes, for everything, right? But at the same time, the cautious has to be taken that is far UVC also good for your skin, or is it just that a dogma that we're believing? So in essence, lot of good technologies, lot of new technologies. It's a very exciting time if you're in the engineering solution side of air manufacturing technologies. But at the same time, as someone that is focused, as a company, we are focused on human health. We can't really say that we have to use the cutting edge technology today if it is going to have even a small chance of affecting the human health negatively in the future. So that balance we always play. We always have to play that balance, and data and insight is the best way to maintain that balance.
Thank you, sir, for sharing this. Since we have reached the end of the session, I would like to ask Ms. Priyanka to summarize the whole webinar in short.
Thank you, Darshana, for putting me on spot. But yes, it was really a very insightful discussion. So, what you tried to set the context on pollution, and majorly my focus has been on outdoor and ambient air quality. But it was really good to hear Vikas talk about the use of IoT. So, and then he also talked about certain challenges that are there in using IoT, and I mean how IoT can help address certain challenges in the air handling units. Followed by a very interesting presentation from Lijo, where he gave a case study and talked about one major insight where there is data from monitoring, but if there is no insight from that data, usable insight, then you don't really need any of such devices. So data along with insights. So it should be data plus information always, right? Followed by a very insightful presentation from Abhinav, where he talked about a live case of operational cost and how it translates into user seeing the results of using such units, and how you can motivate people to take up air handling units and make their employees breathe better. And the point where he actually converted the whole so that is the kind of insight I was talking about, where he talked about that if an organization has to choose between providing a tea per day to providing better air, then obviously they should go with better. So it was really a very insightful presentation, and thank you to you and the TCBU team for inviting all of us and giving this platform to share our knowledge, or the knowledge that we bring in on pollution and handling indoor air quality.
Thank you, panelists, for exchanging your valuable thoughts on today's air handling technology, optimizing indoor airspace.